using remote sensing to assess shrubland vegetation responses to large-scale juniper removal. Again, Joe Smith at University of Montana, Andy Klein-Hesselink, who was working for us, who since went to UCLA, our tech guru, Jeremy Maestas with the West Technology Center, Scott Morford in our lab, and Connor White, who has worked in both of these landscapes and did an amazing job at keeping spatial databases that make these kinds of cross-boundary public-private analyses possible. Conifer expansion is a global phenomenon altering structure, function, and biodiversity on every continent except Antarctica. As you saw earlier today in Kevin's talk, about 21% of degradation of core and growth areas and ecological integrity in the SCD are attributable to this threat. Spatial coordination is everything moving forward from a sagebrush conservation perspective, not just private. SGI can't do it alone, or we end up with a checkerboard pattern. Public the same way, state lands, everybody's got to be on the same page. These things have happened in the past where it spurred public and private partnerships to restore integrity. I'm going to talk about two of those today as we test the effectiveness of two removals at watershed scale. We're just evaluators. I cannot give this talk without backing up, talking about the proactive planning that took place, the NEPA on public lands, if you've ever lived that in your career, everything that had to be pulled lever-wise to make these projects happen, BLM, Fish and Wildlife Service, the entire DOI, state of Idaho, right? Department of Lands, Game and Fish, their Office of Species Conservation has been huge in all of this, and Working Lands for Wildlife has played its role with NRCS. The two places I'm talking about are the Owahis and Burley. You can see a map of each one. Oahe is in southwest Idaho. That's been going on since 2004 to present, and I tried to put some acreages. The two treatments we'll talk about today are cut and lop and mastication, and then we'll compare those conifer removal treatments to wildfire in the same landscapes. But we're talking huge watershed scale types of projects. If you have trouble reading, it's cut and lop, and the arrangement of those treatments is in green, and in orange are mastications. If you don't experience conifer removal too much in where you live and your job, here's a little bit more of it. Cut and lop treatment is in your upper left, where the trunk is sawed at the base, branches are lopped and spread out below 4 feet, try and get it below the height of the sagebrush. On the right-hand side is a mastication treatment where the larger equipment comes in, and yeah, it's fun to watch. And you watch that tree explode and it's scattered by the mechanical movement. If you back up in these treatments a little bit, you're seeing a pre-site and a post-treatment on the lower right. Our objectives here were to quantify post-treatment changes in vegetation, evaluate treatment effectiveness, compare vegetation outcomes of mechanical versus wildfire, and then determine the net effect of conifer removal, going right back to those sagebrush ecological integrity scores. I'm going to show you a lot of the graphics on the right. It's a really data-heavy talk compared to the last one. I want to show you how to read these. So the y-axis is going to be deviation from undisturbed. It's basically percent cover. This is a rangeland analysis platform, satellite remotely mapped type of evaluation. You'll see 4 lines of different colors. The purplish is less than 1% conifer cover, and then you walk through the 3 phases of conifer that I'll talk about in a minute. This is sort of how people that do this a lot talk about it: phase 1, phase 2, phase 3. The x-axis is years before and after the disturbance, And then you'll see, like at the top here, you'll either see cut and lop or mastication or wildfire from a treatment disturbance perspective. It's my only method slide. In the big picture, model selection supported two big things. One, talking about encroachment as phases instead of just percent cover. This came out of Joe Smith's brain, and I just love the eloquence of his analysis and the simplicity in the way you can talk about it. Second is, I'm not going to show you a graphic for one study area and the other, because AIC very much supported the combination and the generalizability of outcomes, which I think is really nice from a management uptake perspective. Oh, that red circle on every one of those graphics, it looks like an anchor point. There was a recent paper by Fick talking about what determines the effectiveness of PJ treatments, and they used remote sensing, and they used a counterfactual approach. Think of this as untreated control sites. And so we have the treatment, but then we used RAP and 18 environmental variables to find similar pixels that weren't masticated or cut and lop. And so with time and space mapped, you can sort of back build a Baki design. If you don't live in a pinyon juniper management world, here's the three phases to at least give you a visual. Phase one is a couple trees per acre, sagebrush, deep-rooted perennials, they're still the dominant. Phase two, we didn't do anything. They move out farther into rangelands. Now you've sort of got a fight for dominance between rangeland vegetation and trees. And phase two, I think this picture was called Grouse Ridge, not anymore. All right, so let's jump into outcomes. Here's the best way to do this. Column one is cut and lop. The middle is always going to be mastication, and wildfire is going to be on the right. The phases fan out like that. Again, purple's less than 1%. Phase three is yellow. This is the vegetative outcome for tree cover. Notice that effect sizes are directly proportional to tree cover at the time of treatment. They really fan out in at least what I interpret to be a predictable fashion. Both treatments, and when I say treatments, I mean lop and mastication, produced persistent effects of tree removal over time. Wildfire had significant but smaller effects across all phases except for the 1% cover that basically rode the zero line. And effects in phase three began to decline in magnitude after 2 to 4 years post-treatment. So you see that dip in recovery in the wildfire relationship. Let's go to shrub cover. Same setup. Treatments increase shrub cover among later phases. So the treatment happened, and then we got the advantage of looking 7 years, 8 years, all the way up to some treatments 14 years old. They had little effect on earlier phases. You can see where the pink and the purple ride the line in cut and lop on the left-hand side. Wildfire strongly reduced shrub cover where tree cover was low. Go over to the right-hand side and see the pink and purple. And were nearly unchanged in phase two and increased in phase three and then leveled off. It's a big advantage to have time covered over multiple years. Positive treatment effects in phase three sites continue to increase in magnitude through time, except for wildfire. So the big phase three yellow lines and treatments keep going up in terms of shrub recovery, but it leveled off with wildfire. Let's go to perennials now. So deep-rooted perennials. Treatments, lop and scatter and mastication, increase perennial cover across all time periods and phases except for less than 1% for cut and lop, where on the left-hand side you see purple riding the line. We observed greater perennial responses across later phases for both cut and lop and mastication. Everywhere we saw a pop in perennials post-tree removal. It's probably the biggest message. And then perennials increased following wildfire after initial declines in earlier phases. So in wildfire, you can see that initial dip for places that had few trees. Effects then stabilized and declined where trees were densest. I'm looking at that leveling off and decline in phase 3 yellow for wildfire. The last one of these is annual foreign grass cover. Annuals increased with all treatments with a short lag with wildfire. This is the annuals are kicking our butt. And so the other, I hope everybody's looking at the y-axis going like 30% cover annuals? No. Lop and scatters all the way from maybe 1% compared to the heaviest tree cover where it went above 5% and then declined. Look at mastication. Mastication went all the way up to 13, 14%, but in year 7, as we were able to track this farther, that annual cover got cut in half. Perennials started competing better, probably did some seedings, some aerial work, that kind of thing. Effects of wildfire were less clearly related to pre-treatment tree cover. All right, now I got to explain 2 more graphics. Here, we took a little deeper dive on wildfire. That top row is all rangeland analysis platform related again. Green is lop, blue's mastication, and red is wildfire. Here's the key on this one. The y-axis up and down on the top figure is a ratio. So it is the ratio of perennials to annuals. Above the dashed line is where perennial cover is 2 times that of annuals. See how we're trying to get to like competition? Do annuals start winning all the time, or do perennials come back with a vengeance? How's that happen in space and time? The big picture here is that as you look across time, the blue and the red boxes hold their own and perennials get better. Wildfire, degrade, 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 and 7 years or more after wildfire, the ratio of perennials to annuals actually drops below 2x. I say get after trees, defend the core, and go in and fix annuals if you have to. Oh, nah, don't wait for wildfire. It's going to eat our lunch even more. The bottom one, Joe Smith said, let's take one more look at shrubs. That's just simply shrub cover. Shrub cover remains persistently low following wildfire, like 12% cover. Shrubs come back with conifer removal over time and hit that 19 to 20% cover. So there is a big difference between defending the core by getting rid of trees and waiting for wildfire and suffering the consequences. Now, let's wrap this back to the sagebrush conservation design. The Owahis on the left and Burley on the right. These are those 5 grades that you got on your report card over time. When you look at the first 3, perennials, human modification, and sagebrush, they're fairly flat. The action is in the brown line, which is the ecological integrity of trees. Prior to cuts, watch the brown lines. The one in the Owahis, poorer grade, poorer grade. Oh my God, I got a D on a test. And then it levels off. We halted the decline in ecological integrity in the Owahis. In Burley, declining, 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 and we actually bent that curve, started scoring better, and our ecological integrity's taking off because of our conifer removal management action. Then you look at annuals. Annuals are that lowest yellow line. They're the most variable of any of the ecological integrity scores, and they continue to go down through time. So we're gonna have to get back in there in the Great Basin. And if you're connecting my first talk to my second one, these are 2 of the 9 legacy landscapes that I had talked about earlier. But if we wanna jump that hurdle and get these degraded or growth areas back into core status, which Tina tells us is so important, we're gonna have to stay there because these landscapes are conservation dependent. In closing, Oahe and Burley are incredible public-private land partnerships, things we can see, learn from, and go replicate in other high priority areas. We can quantify these outcomes now from space with satellites. Should save us a lot of monitoring money in some instances. Findings show that properly targeted and sustained conifer removal restores the ecological integrity of these sagebrush landscapes. Despite the beneficial outcomes of conifer management, follow-up treatment of invasives would safeguard these initial investments. I want to back up on fire. Please don't leave the room believing that we don't think prescribed burning could be good. This was wildfire. We think what's going on is we did not cut trees, we did not stop grazing to increase fine fuels like you would in a prescribed burn. Instead, these were probably highly mosaiced. They left a lot of trees on the landscape, which brought us into that problem of a spreading seed source and gave us this really patchy landscape. I'm with Chad Boyd and his paper about the habitat mortgage and our likely inability without prescribed fire in the right places with high elevation and lots of moisture, we probably aren't just going to cut our way out of this problem. It's desirable to see what Burley Bosch have done, learn from these geographies, and then where there's community readiness and the types of administrative conditions that can be produced to really scale things up with practitioners that Ken alluded to, we should learn from that and go replicate. Thanks.